Hi everyone. So today we are going to be going over the greatest common factor. This is just a recap. I'm going to go over two different ways on how to find the greatest common factor. And the reason why we want to make sure we review this topic is because these usually come up on the ACT in the form of word problems. So let's go ahead and get started. So again, the greatest common factor, we call it the GCF, is the largest number and or variable that is a factor of two or more numbers. So I can find the GCF of 2, 3, or even a greater amount of numbers. And I can also do it with expressions where the numbers have a variable term attached to it. So when looking for the GCF, you are looking for the common, so let's fill that in, for the common factors contained in both numbers. So what is common between the two, the pair of numbers or the three numbers and so on? So if there is no such factors, meaning that there's nothing in terms of common numbers that they both have in common, then one is the greatest common factor. So again, if there's no number that divides into both of them, then the GCF is 1. So again, always think of the GCF as the biggest number that divides into both numbers. So again, what divides into both numbers? And if no number besides 1 goes into the numbers, then the GCF can be 1. So it's fair game. So let's go ahead and look at the two methods I just mentioned that we're going to cover. So the first method just has to do with factor trees, which is what we went over yesterday. So if you can make a factor tree, you should be okay with method 1. So again, first thing in method 1 is you make your factor tree. So here's an example on the right of that factor tree of each of the two numbers. Then you find and circle the common factors. In this case, you can see the 2 and the 3. They both have both a 2 and a 3 as a common factor. And then you just go ahead and multiply those numbers. So here. So that tells us here that our GCF is 6. So I'm going to write this down. GCF here is 6. So let's go ahead and do some examples on our own where we create the factor trees, we circle the common factors, and then we identify the GCF. So let's start with number 1. So we have 18 and 30. So I'm going to go ahead and do 18 here. I'm going to separate the 18 and 30 so I have room for my two factor trees. So here we have, let's go with 6 times 3 is one way we can do it. Then we're going to go ahead and split this to 2 times 3, and then just bring down our 3 over here. All right, let's go ahead and do 30. We can do 3 times 10. 10 can be 2 times 5, and I'm just going to bring down my 3 here. All right, so I've broken these both numbers down all the way to their prime factors, meaning I can break them down no more. And now I'm going to go ahead and circle, which now I'm on step 2. I'm going to circle what they have in common. So I'm going to circle a 2 on the left and a 2 on the right. They both have a factor of 2 in common. I can also see that they both have a 3 in common as well. So my GCF in this case is the number 2 times 3, or just 6. So that's pretty much the general idea. Let's go ahead and do number 2. So I'm going to go and take my 14 and my 20. I'm going to make sure I separate them. So let's just kind of separate that so we don't confuse ourselves. So 2 times 7 is 14. I can't break it down any further, which is nice for some of these problems. And here we can do, let's say, 4 times 5. And let's go ahead and break down that 4 a little further to its prime numbers, 2 times 2, and bring down that 5. So we have our prime factorization here from our factor trees. I'm going to go ahead and circle now what they have in common. I notice that they both have a 2 in common, so that's a factor they have in common. Are there any more factors? 7's on the left, 2 and 5 on the right, they're different. Therefore, I can now identify my GCF. So here the GCF comes from just the 2 that they have in common. And we're done with that example. Let's go ahead and move on to the next one. Let's move on up. All right, let's go ahead and look at example number 3. So in this case, we have 3 numbers. So we're going to find the GCF among 3 numbers. So I'm going to have 12, 18. I'm going to space them out a little bit. 24. So 12 is 6 times 2. And you can do that 3 times 2 and bring down the other 2. All right, 18 we can do 9 times 2. And 9 is 3 times 3. and bring down the 2. 24, I can do 6 times 4 and 3 times 2. Break that 4 down to 2 times 2. All right, so I've got my prime factors, which is step 1 from the factor trees. Now I'm going to find the common numbers among all 3 now. Since I have 3 numbers, I have to circle it from all 3. So what do they have in common? I notice all of them have a 3. So I'm going to take my 3. They all have a 2, so I'm going to circle a 2. And that's it. The middle one does not have a second 2, so the 12 and the 24 have another 2 to circle, but it has to have the common term for all 3. The 18 does not have that 2. So my common factors are the 2 and the 3. Therefore, my GCF here is going to be 6 from the 2 times the 3. Let's get into our last example, which is 15a cubed and 18a. So we can be finding common factors from expressions that have variables as well. It works the same way, so don't be too confused by it. Let's go ahead and look at an example and it'll make more sense. And then we have a cubed and a. So I'm going to break down the 15 to 3 times 5. Let's fix that 5 a little bit. And the a cubed is just 3 a's multiplied. 1, 2, and 3. The 18 is 9 times 2. We just did this one earlier. 3 times 3 times 2. And I'm just going to bring down my a in the back. All right, so we are going to go ahead and circle common factors. So both of them have a 3, and both of them have 1a. And that seems to be it. So my GCF in this case would be 3 and an a. So we just put them side by side. If they're side by side, they're being multiplied. It's a product. So this is pretty much how method 1 works for the GCF. You break down your factor trees, see what they have in common, and multiply. All right, let's go ahead and get into method number 2. I kind of like method number 2. It's a nice little different method than doing the factor trees, especially if you don't like factor trees, and there's not as much breaking down to do. Now the directions look like there's a lot more going on, but it's really not that bad. It just has to explain it. So first set of directions says place the numbers inside the upside down division, which is this guy right here. So we start with this right here. You divide the numbers by a common factor. So in this case, the numbers 160 and 144 are divisible by 2. That's why this number 2 is on the left. So divide the numbers by a common factor. That number goes on the left. That's step 2. And the solution after you divide by 2 goes here. So after I divide these numbers by 2, I get 80 and 72. Then step 3 is we're going to repeat it again. We do another backwards division sign, and this time we're going to divide by 8. And when I divide by 8, I get 10 and 9. And we would keep on going, but 10 and 9 have nothing in common, so we can't divide 10 and 9 by anything because they're relatively prime to each other. So we're going to go ahead and stop there. That's step 3. And then number 4, which is how we get our answer, is the GCF is the factors on the side. So it's the numbers on the side. You see that these circled in red here? And you just multiply them, and that gives you your GCF of 16. So let's go ahead and see how this works. So let's do 8 and 18. So we do our backwards division. We put an 8 and an 18. We ask ourselves, what divides 8 and 18? We can divide both of these by 2. So I'm going to place a 2 on the outside here. And when I divide by 2, I'm going to get 4. And divide the 18 by 2, I get a 9. Now I ask myself, is there something I can divide 4 and 9 by? And there is absolutely nothing that divides into both 4 and 9. So my answer is just going to be what's left on the left side. So my answer, or my GCF, is just whatever's on the left. So in this case, my GCF is 2. So it's a number that divides into both 8 and 18. If I did the factor trees, I would end up with the same answer. Let's go ahead and try one more time. So backwards division sign. Put the 2 numbers in there. Ask yourself what divides into 24 and 36. So we can go ahead and say we can divide these, and there's more than one way to start this one off. I'll start with a smaller number. Let's go with 4. So these are both divisible by 4. So 4 goes into 24 6 times, and 4 goes into 36 9 times. Then we do another backwards division. What divides into 6 and 9? Both of them are divisible by 3. So I'm going to put a 3 on the outside on the left. And what am I left when I divide by 3? I'm left with a 2 and a 3. Does anything else divide into 2 and 3? No, because they're prime. So my GCF would be those numbers on the outside, which is this 4 and this 3. So my GCF is just the multiplication of 4 and 3, which is 12. Let's go ahead and try one with expression as an x variable is present. So we're going to have 16x squared, and we're going to have 40x5. Now it works the same way. Just look at your numbers first. What divides into 16 and 40? You can say 4 divides into both of them. They're multiples of 4. So we're going to divide by 4. We have 4x squared, and we have 10x to the 5th. All right, what else divides into 4 and 10? We can say 2 divides into them, so backwards division. We're going to say divides by 2. When I divide these by 2, what do I get? I get 2x squared. And I get 5x to the 5th. So I asked myself, what divides into 2 and 5? They're prime now, so there's no more division on the numbers, but we can continue this process with the letters now. They both have x's in common. So how many x's do they have in common? They both have 2 to divide out. So I'm going to put x squared out here. You want to do it one at a time, you can. So I'm going to put x squared because they both have an x and they both have a second x. So I'm going to be left with just 2. And I'm going to be left with x cubed here because I took out 2 of the x's. So I no longer have any more common terms. I'm going to circle what needs to be multiplied in order to get my GCF, which is these 3. So if I go ahead and multiply them, my GCF will be 4 times 2, which is 8, and I have the x squared on top of that. And last one will be just a ladder method of the GCF with 3 numbers. So same idea, just what divides into all 3 numbers. So what divides into all 3 of these numbers? We can say the number 2. So I can divide these by 2. What am I left with when I divide by 2? I'm left with 2 here, 3 there, and 6 here. Does anything divide 2, 3, and 6? Nothing divides into all 3 of them because 2 is prime and so is 3. So my GCF is just going to be the number 2. All right, let's go ahead and move on to the very last example, which is a word problem that involves the GCF. So it says Maria has 160 pieces of chocolate candy and 144 of fruity candy. She wants to give each child the same amount. So I'm going to underline this part of candy so that no one feels left out. What is the greatest number of children she can give candy to? So here are my key words here. Same amount, which is a common amount, and the greatest, which is the biggest one. So she can give them all 1, she can give them all 2, she can probably give them all 10. So we want to make sure that this goes into our greatest common factor because we want the highest amount for each child. So we're going to go ahead and do 166 and 144. So I'm going to go ahead and do the ladder method on this one. You don't have to do the ladder method. If you prefer to do the factor trees, go for it. So let's go ahead and see. I know they're divisible by 2. So I know I can divide these by 2. So 166 divided by 2 is 83. 144 divided by 2, we're going to get 72. Oops, I just realized I made a mistake. It was not 166, it was 160, which means this is now an 80. My apologies. All right, let's go ahead and continue this one. All right, let's go ahead and ask ourselves, we can still divide these by something. So what's a number I can divide both 80 and 72 by? And a number that divides both of these is actually 8. These are multiples of 8. So I'm going to go ahead and write that out. So 8 into 80 is 10 times. 8 into 72 is 9 times. All right, so we're going to go ahead and move on from here. Let's go ahead and figure out our GCF now. So remember, our GCF is on the left, so 2 and 8. So my GCF would be 2 times 8, which would be 16. So this tells us that Maria can give candy to 16 children. And just as an FYI, as it's extra, these bottom 2 numbers actually tells us how many pieces each kid would get. So each kid would get 10 of the chocolate and 9 of the fruity candy. So now that you're done, go ahead and get started on your practice pages, and good luck.